so the application problems. Alright, so find two consecutive integers whose product is 132. Well, product means we're going to be having multiplication of two numbers. Two consecutive integers, okay, just consecutive, that means one after another. So like 6 and 7, 8 and 9. So therefore x and x plus 1. So all we're going to do is do x times x plus 1 equals 32. Now, of course, being guess and check, you could just, guess numbers and check them, but you need to know how to do this mathematically. So this is x squared plus x equals 32. We move the 32x over. Now we're looking for two numbers that multiply to give me 32 that differ by 1. Okay? Sorry, it's 132. My brain is not working because that wasn't going to work. So we need the numbers that make 132. We can use our calculator and test different numbers, and we're going to find out that it's 11 and 12. 11 times 12 is 132. Now, since we want more positives than negatives, that looks like that. But when we set these both equal to 0, we get x equals positive 11, x equals negative 12. Okay? And interestingly enough, both of these actually work. Now, a lot of times we're used to throwing out the negative, but that's when we're talking about real-world problems, like you can't have a negative distance or a negative time. But in this case, 11 and 12 make 132. 11 and 12 are consecutive numbers. Well, negative 12 and negative 11 are also consecutive numbers, and they also equal positive 132. So it's actually both answers. We don't throw out the negative in this case because we're just talking about numbers. Now, talking about product again. Two consecutive, but this time we're talking about even numbers. Now this throws people off sometimes, especially comparing number 2 and 3. Think of two even numbers, 6 and 8, 10 and 12, 18 and 20. Those differ by 2. Okay, but this 2 right here has nothing to do with it being even. In fact, we're going to jump ahead and talk about the two consecutive odd integers are also going to be x and x plus 2. Think about 3 and 5, 35 and 37. They also differ by 2. The 2 has nothing to do with even or odd. It just means every other number. So in this case, the key is that number is odd, this number is even. Okay? So we're going to have x times x plus 2 equals, let me do it right this time, 224. X squared plus 2x equals 224. Move the 224 over. Now we got to find two numbers, and we're just going to use our calculators here that make 224 that differ by 2. When you do that, you're going to get the numbers 14 and 16. Well, we want more positives and fewer negatives. Now, when we solve this, we're going to get positive 14 and negative 16. Like the previous question, we plug 14 in, and add 2 to it, we get 16. But if we plug negative 16 in and add 2 to it, we get negative 14. And those are two consecutive even numbers. All right, same setup. X times x plus 2 equals 99. X squared plus 2x. I'm just going to move the 99 over right now. I think you've got the gist of it. Then here, two numbers that multiply give me 99 that differ by 2. Hopefully, without a calculator, you realize that's 9 and 11. Now, again, I want more positives, fewer negatives. So that's going to lead to x equals 9 and x equals negative 11. Well, once again, when I plug 9 in, 9 plus 2 is 11. But when I plug negative 11 in and add 2, I get negative 9. And those also give me a product of 99. So you want to have both answers. Whoops. Okay, number 4 is a good one where it helps to draw a picture. So we have Fred's closet. Okay. Always look for this comparative term, and that's going to tell you where to start. Then the width. We're comparing to the width. So we're going to name that, use that for our variable. And then the length is 2 more than the width. Now the area, which is length times width, is 24. So this is going to be just like the problems above us. W times W plus 2 equals 24. In fact, this is just a word problem version of 2 consecutive even numbers that give us 24. Number 4 is no different than number 3, except it's a word problem. That's it. So we're going to get W squared plus 2W. Again, I'm moving the 24 over right away. Now I'm looking for 2 numbers and multiply, give me 24 that differ by 2. Well, it's going to be 4 and 6. I want more positives than negatives. So that gives me x equals 4, x equals negative 6. Now, very important, this is where we throw out the negative answer because we cannot have a negative measurement. So, what is the length and width? The width is 4 feet, and the length is 4 plus 2, 6 feet. Once again, if this was not a word problem and I just said 2 consecutive even numbers, if product is 24, same problem. The only difference is the answer is just the positives in the real world. Okay, the length of a picture frame is 5 inches more than its width. So that's going to be our starting point. 5 more than the width. Well, same setup. W plus 5 equals 50. W squared plus 5W. I'm just moving the 50 over right now. I need 2 numbers and multiply to give me 50 that differ by 5. And that's going to be 5 and 10. 10 times 5 is 50. 10 minus 5 is 5. I want more positives than negatives. This gives me W equals 5, W equals negative 10, which we will throw out because we cannot measure something negative 10 inches. So the width is 5 inches, and the length is 10 inches. Okay. Pumpkin is launched upward 64 feet per second. Notice where that 64 is. This is the velocity. From a platform 80 feet high, this is where it started. Okay? So, if you look at this graph and you count by tens, I'll put 20, 40, 60, 80. This is where it's starting. Okay? It's starting 80 feet high. It's going to go up in the air and then hit the ground. Now, it says, how high will it be at 1 second? Well, let's use our calculator for this. Okay? So we're going to put this in. Clear out anything else we have in here. We have, remember, use negative, the little negative key, 16x squared plus 64x plus 80. And then we graph that. Now the thing is, this is going to be off our chart because 80 is way up in the air. Our y-intercept of 80 is way up there. But we can still use a table. We want to know where it's going to be in 1 second. Well, once again, there you see 0, 80. So for 1, it's going to be at 128 feet. So let's see, if I may have to change my dimensions here. 90, 100, 120, 140. That'll work. It's okay. So where will it be at 1 second? Again, according to the calculator, at 1 second it'll be at 128 feet. So at 1, I can go to, here's about 128 feet. Now the maximum height. This is where we have to take the opposite of B over 2A. Okay? So 64 divided by 2, sorry, 16. I got 16. So 64 divided by 32 is going to be 2. So in 2 seconds, it'll be at its maximum height. So we look at our calculator, 2 seconds, 144. So in 2 seconds, it's going to be about here, just a little bit off the graph. Now, where will it be for the rest of the graph? At 3 seconds, it'll be at 128 again. At 4 seconds, it'll be at 80, and 5 seconds, it'll be at 0. And then we just draw our graph. Okay? So it says, how long does it take the pumpkin to reach maximum height? Well, that's going to be 2 seconds. And let's just throw it in there. It's not asking the question, but it's 144 feet in the air. When will it hit the ground? That means when is x0, and that is 5 seconds. A height of 0. That was not supposed to happen. Let's put this back here. Try that again. Okay. So Sarah's taking her math textbook, top of a 12-story building, and looks at the pool, which is 160 feet below. She throws her book down at 48 feet per second. So again, velocity, and initial height. So we're not going to be able to fit, obviously, from the previous one. So I'm going to have to count this time by 20s. So 40, 80, 120, 160, 40, 80, 120, 160, 200 should be up here. And then 240 up here, and 280 up there. Okay, so how high will the object be at 4 seconds? Well, we're going to put that in our graphing calculator and change it up. So we go back to y. And notice all I have to do is change a couple numbers. So 48. And then need to change this to 160. And then graph. And it's going to be off the chart again. But if I go to my table, I know it started at 0, 160. So that's my starting point. And at 1 second, it's going to be at 192. And at 2 seconds, it's going to be at 192. So obviously, the vertex is somewhere between 1 and 2 seconds. So 192, let's just say about here and about here. We're estimating. And at 3 seconds, 160 again. And then 4 seconds, 96, and 5 seconds, 0. So 100 is right here. Wait, 1, 2, 3, 4, 5. This is 0, sorry. And 96 is going to be, right about there. So where is that vertex? Well, first off, at 4 seconds, where is it? At 4 seconds, it's at 96 feet. When will it hit the ground? Again, 5 seconds. Now, just for the heck of it, what is that vertex? Well, let's find out. So, this bonus material, the vertex, opposite of B over 2A. Well, that's going to be 48 divided by 32. Which you can probably guess what it's going to be from looking at the screen, the table. 48 divided by 32 is going to be 1.5. Which is not on here, is it? So you can plug 1.5 in, or here's a little trick. If you go to the table and just change it to starting at 1.5. Well, no, let's just keep it at 0. But watch. If you tell it to change instead of 1 to 0.5, now you will see 1.5 is 196 feet. So I obviously went a little too high with that. Let's fix that. It's going to be right about here. So just under 200. And that's it.